So just wanted to say thanks to our final kind of gold level sponsor, Linode. Linode is all SSD Linux servers, really fantastic, super high performance. They just came out with a $5 1 gig server, which is great. My company personally uses at least 10 Linode servers, maybe more, to run a whole bunch of different services and websites and everything. At this point, we just spin up new Linodes every time we have something new. So I personally recommend them. And they've always been a big supporter of Laravel and Laracon. So definitely check out Linode. Again, say thanks to them on Twitter if you wouldn't mind. That's always great. But most importantly, go check them out if you're looking for really high quality servers that are extremely ridiculously affordable. Then check out linode.com. Definitely my personal recommendation. Love those guys over there at Linode and gals. Okay, so we're now going to pass it over to Matt Stauffer to bring us home. Bring us home after this long day. I'm super excited. It's going to be awesome. So go ahead and you can take control of the screen, Matt, and take it away.
All right. Everything looking good?
Yep. Looks good.
Right. All right. Well, today we're going to be talking about mastering the Illuminate container. And if you're not familiar with the Illuminate container, it is essentially the glue that takes the entirety of the Laravel framework together in one. So I actually wanted to show off the fact that one day, a long time ago, I learned Photoshop. So this is the Illuminate container. Just kind of get this picture in your head. If you've seen me give talks before, I like kind of one picture in your head. The last time it was the ship it scroll, which I think was a lot more memorable than this glue, but I didn't have a lot of time. So you got to stick with me. So we got glue, we've got the Laravel logo, and then we've got cubbies, which I stole from target.com. And so we're going to be basically taking things in and out of this container throughout the whole time. So we're going to talk a little bit around the container before we actually get to the container itself. So the first thing we're going to start with is, what is the container? And interestingly, you'd think that asking that question is talking about the container, but in reality, you're really talking about what is Laravel itself. If you think about Laravel, Laravel is essentially a series of conventions. It is this goes here and this lives there and that talks to this and this should be named that. It's a series of packages, the Illuminate packages. So it's going to be Cache or it's going to be Eloquent or whatever else. And then it's a container that is the glue, the skeleton that puts all those pieces together. So the container essentially is the backbone of every Laravel application. And without the container, a new Laravel project is really just conventions and packages. And that's not just because they're amazing packages and well thought out conventions, but the container is the piece that wires everything together. It's the glue. It's the glue with little cubbies in it, essentially. So if you think about any of the key pieces, and these are just a few of Laravel, each of these relies on, is called by, and pulls dependencies from the container, whether it's routing, whether it's the middleware, the entire middleware stack, it's the request object, we learned about it earlier with Taylor talking about it, or constructor injection in any of our classes, or even facades, which everyone loves so much. All of these rely on heavily and deeply interact with the container. So it does lots of stuff. It's magic. But what is it and what does it do to make all this magic happen? Interestingly, the framework and the documentation actually reveal a little bit to us of what it is and what it is that it does as we talk about naming the container. So let's take a quick look at what a couple different sample things are for names that would be used to refer to the container. So one is the container. It's probably the most common name, also called like the service container at times. But also it's the application. The thing that you're using most often when you're saying I'm working with a container is actually a very light class that's application that extends container. So it's the application, which makes even more sense for it to be the core. It's also the IOC container or the DI container. I think the IOC and DI reveal the most about what it is if we're still trying to figure out, well, what is it other than this thing that I call Macon sometimes or whatever. So let's take a quick pause and say, what is DI and what is IOC? So DI is dependency injection and IOC is inversion control. And both of those are things that the container does. It's a DI container, it's an IOC container. So dependency injection is assuming that any given object has dependencies. It's things it needs from outside of itself in order to do its job. And common dependencies, which I'll use often, are things like a logger or an emailer or something else like that. So dependency injection are where instead of that object creating, newing up those dependencies internally, instead expects them to be passed in from the outside. And that's the general concept of dependency injection. And especially when we're talking about a framework or a package, it's when there is an external object that is responsible for supplying those dependencies in. So you've got an object, it can't do the work on its own, or it shouldn't. It expects them to be passed in externally, and a dependency injection package, tool, framework, whatever, is the one that is responsible for supplying those dependencies in or injecting them in, usually via the constructor. And inversion of control is, it's a little more complex, but in this particular context, the best way to think about inversion of control is that we're going to define once at the framework level how to implement a specific feature, or how to implement a specific code path or a specific interface or whatever else, instead of defining it every single time we're doing consuming code. So if you think of the fact that any given app may have 20 or 30 times where it sends an email, if every single time you send that email, you have to say new mailgun mailer, send email, blah, 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 what happens if later you want to change your mailgun mailer to something else? And of course, this is one of those, like, it's a made up example. It's not like that happens all the time, but half of the programming world did recently leave Mandrill for something else, and anybody who used Laravel was very, very grateful that it does inversion of control, which is the fact that every single time you're sending a mail, you just say send mail. You don't say send mailgun mail, you said send mail. And one time at the top, the control of this specific details happens at the top, not at the bottom. And so things are inverted. And there's another way to look at it where it's really now the bottom that has the control, whatever. In the end, the bottom is requesting a mailer, and the top is defining which mailer should be provided, or whatever else. So if you hear those two things, it makes sense that that's what the container does, because it's the container to which we're turning to get those dependencies. It's a tool that enables dependency injection. It's a tool that enables inversion of control. It makes it possible for you to structure your PHP applications using dependency injection, and therefore it enables inversion of control. Okay, so that's kind of like why those terms are useful for us, because we now start to really get a sense of what the container is for and why it's so valuable, why, as Taylor talked about, it's good to use in other projects. I mean, the reason I first got connected to Laravel, other than the fact that I respect Jeffrey Way a ton, had followed him for years, and when he said Laravel's good, I said, okay, that's probably good. But also, I was looking for an IOC container on a CodeIgniter app, and I finally found one written by this young guy named Taylor Otwell, and it looks like it had been deprecated. And I reached out and I was like, hey, Taylor, I'm really looking to use that thing that you wrote. It's really great. What happened to it? And he's like, oh, I built it in this framework, Laravel. And I was like, okay, cool. So like, it's, this is a big piece of it. It's really important. So remember, the container is the glue. It is the backbone. It is everything that puts all your other pieces together. It takes all your packages into one, it indexes them, it binds them, and it makes them available to each other and to your calling code, whether it's in a controller or a command or a job or whatever else. So let's talk for a second about the practical things you're going to do with the container. The two primary pieces, there's other stuff, but the two primary things you're ever going to do with the container are bind and resolve. And if you imagine those cubbies on our Elmer glue, a cubby is basically a slot that's waiting to have something put into it, then later can be pulled back out, right? And so binding a class or an interface or whatever else to the container basically means you're taking something, whether it's a mailer or whatever else, and you put it in a cubby. And then resolving is being like, hey, Elmer's glue, give me a mailer. And it kind of says, oh, well, here's my mailer cubby. I'm going to hand it back to you. Those are the two things, binding and resolving. So let's walk, maybe not through the way you do it every day, but I want to kind of walk through the concepts around the container in a simple way so that we can get to what you might be doing on a more regular basis. So there's a lot of different ways to get an instance of the container. Often you'll actually get one out of the container by all this other stuff we'll talk about later, but let's just keep it simple here. Just imagine when you run this app helper function, it gives you the container. That's all you need to know for right now. Great. So you've got a variable container, app returned it to you. Now you're ready to do some stuff with it. Now let's resolve an instance of something else using the container. So remember, resolving is taking something out of a cubby, right? It might not make sense about why we're taking something out of the cubby before we put something back in. I promise it'll all make sense in a couple minutes. So the first thing we're going to do is we're going to say, I want a logger. I want to be able to log an error. So you get container equals app, you got your container, and then you say your logger equals container make, and then you pass the full namespace of that class, which is the log writer. And so now you have a logger, and now you can say logger, arrow, error, whatever else, and it's ready to go. There's a shortcut to that, which is you don't have to set container to be a temporary variable. You could just say app, and then on the responsive app, you just run arrow make Illuminate log writer class. Great. You can do that. You drop the instance, but even shorter you can actually just pass the class or the key that you're trying to look up directly into app. Now, there's a lot of things you can do in the container. Make was not the only one, but make is the most common one. Therefore, if you pass that class in there, you can now just get an instance of it. So logger equals app, Illuminate log writer class. Great, we're ready to go. So you're probably asking yourself at this point, why do I not just new that class up? Why does this not say logger equals new Illuminate /log /writer, and that's it? Why are we doing all this complexity? We'll talk about it in just a second. Oh yeah, I have a slide for this. But wait, why is this any better than new thing? Well, let me tell you, friends. So imagine that this is what our make method looks like in application, which remember, application is what we're usually interacting with when we interact with container. All it does is it takes a string, which is key. And remember, the key we just passed a minute ago was Illuminate /log /writer, right? So we said application make Illuminate /log /writer. It takes that string and it says return new space Illuminate /log /writer. Great. So there is no difference yet. Okay. So far it makes sense, but so far we don't know why we're going to use it. So we're going to make a class my class. It has a function called doThing and it echoes ABC. So we say instance equals new my class, instance doThing. This makes sense that we're doing normally. At this point, there's not really a lot of value, right? Instance equals app my class instance doThing. There's nothing better about this versus that. We're just kind of doing the same thing. However, what about if there's dependencies? What if that my class here has a constructor that requires some dependencies? That's when the story starts changing. So now my class has a dependency that is of class other thing or interface other thing. And it needs to be injected in every single time you create a new my class. So you say instance equals new my class, just like we were talking about a second ago, and you get an error. Argument 1 passed to my class construct must be an instance of other thing. None given because we didn't pass anything in. Okay, we all know that's a problem. So you could theoretically say instance equals new my class, new other thing. But if you've ever done this before, you know that there's also going to be a logger and an emailer and a service and a system and a client and whatever else. And it's not something you really want to deal with. So this is where this starts being a little more helpful because it's going to get clumsier and clumsier. Doing that same thing still looks exactly the same as it did when there were no dependencies. Instance equals app my class. Why is that? How is that possible? It's because of more magic. Not the bad magic that hides things from you, magic because it's beautiful and brilliant. And this particular magic is called AutoWiring. And AutoWiring is a package or framework or tool's ability to instantiate a class without being given explicit instructions from the user of how to instantiate that class. So we saw at the beginning, AutoWiring doesn't provide us any benefit when the class doesn't have dependencies. AutoWiring is the same as writing new, except it's a little more obfuscated. People don't know it exists, so you don't even worry about it. But when there are dependencies, someone somewhere has to explicitly teach the framework or tool how to instantiate something with dependencies. And most of the time, pre-IOC container or pre-DI container, that was by actually newing up all of its dependencies in line and passing them. And there are other DI containers that are DI containers. They make it easier. But if you were to say new my class, in their world, it would still throw an error because you never explicitly taught this thing, how do I create an instance of my class? And we'll talk about how to do that with Laravel in a second. It's manual binding. But auto-wiring frameworks like Illuminate's container say, I'm going to use reflection. If you're not familiar with reflection, reflection is the ability in PHP, and it exists in other languages with different names, to reflect, to understand the shape of a class or a method or a piece of code or whatever. And one of the things we can use a reflection for is to understand the dependencies of something. So if a class has dependencies and the Illuminate container is asked to instantiate it, it reads the constructor parameter list, it reads their type hints, and it says, okay, so I need an email and a logger. So before we make new class or my class, whatever it is, I'm going to go make a new email and a logger. And then it recursively basically says, make an email or make a logger and passes them in there. So AutoWiring Framework uses its intelligence to say, as long as I'm capable of reading those type hints and understanding what your dependencies are, I'll make the dependencies and pass them on in. Good to go. So the difference between an auto-wiring framework and a non-auto-wiring framework is that in non-auto-wiring, if you're still an IOC container, you have to manually new up all the dependencies. In auto-wiring, it can do it all for you. So let's update our sample make method. Take a look at it. And now it is doing auto-wiring. Magically fake with a private method doesn't actually exist. But instead of just saying return new key, it now says get an array of dependencies for that class, right? So it goes to my class and it says, well, what are its dependencies? Well, its first dependency is other thing, I think was what it was, and new up other thing, and then return it in that array. And now it passes in. Now it says return new key, which is to return new my class, and then it passes in the dependency. So we still are able to keep doing this without us ever having taught the thing how to new them up. It's using reflection to figure out the constructor dependencies. And to help you remember this, it's turtles all the way down, which basically means you got one class that has two dependencies. Well, what if they knew up those dependencies and they have dependencies? It's just going to keep going down the road, down the road, down the road until it eventually gets to a class that has no dependencies. And then it passes that one in, passes that one in, passes that one in, passes that one in until you finally get your original one. So this all makes sense. This is cool. This is wonderful. This is, beautiful until you don't know if it's a turtle. And by that, what I mean is, what if one of the dependencies of that dependency or another dependency or anything the whole way down the chain isn't type hinted? Well, remember, we're using reflection to understand the type hinting so that we can figure out what to pass there. What if it's just a string? It's just a variable name, for example, API key. How does the container know how to instantiate this? Look, we're saying service equals at my service class. So we're doing it the same way, but the constructor doesn't have a type hint. It just says an API key. So what's going to happen? An error. Unresolvable dependency resolving parameter number 0 required API key in class my service, which is exactly what we'd expect. Hey, you didn't pass the thing into me that I need, and I can't magically figure out what it is because there's no type hint. And now comes the time for what we talked about already, but we're actually finally going to cover it, which is manual binding, which is the ability for you, when necessary, and only when necessary, to teach Illuminate's container how to specifically define how something should be resolved. So this is not quite 4 types of manual binding. It's really 4 methods, 4 different things you want to do when you're handling manual binding. And the core of it is bind, and everything else kind of centers around that. So when you're binding a class to container, remember, you've got your Elmer's glue with the cubbies in it. What you're doing is you're basically putting something into a cubby and you're putting a label on the top. And so the label's usually the class. And so what we're doing here is we're saying bind this string, which is the class name of my service, the fully qualified class name of my service, to this closure. And if you're not familiar, a closure is an anonymous function. So bind the my service class string name, my service or app/my service or whatever, to this closure. And what that means is any time that the Illuminate container is asked for an instance of my service, it runs this closure and it returns a response. And so look what we did here is we return new my service, but we, in a way that we're capable of knowing, and the AutoWiring framework is not, that's what API key looks like. And in reality, it would probably be set in an environment file that would then be put in your config, and then it'd be cached, and then you'd be using the config helper in here to get it out. But in general, what we're showing here is that you manually had to teach the thing how to resolve that dependency. And so now when we say service equals map app my service class, you're now passing it to this closure, and you're going to get whatever comes out of this closure, which is great. So now you can rely on auto wiring anytime it's type hintable and easily handled. And when it's not, you find all the ones that cannot be easily resolved, and you just pass in its parameters like this. That's the core of binding. Everything else is going to kind of circle around this, but that's really what we care about at this point. But there's a few edge cases, not even edge cases. There's a few other things to consider. So for example, what if it didn't just have an API key dependency, but it also had 2 other dependencies that you did want to auto-wire? Well, take a look here. My service now requires a thing, an other, and an API key. Well, it turns out that the parameter that is passed in that closure is an instance of the container. And you can use that container to make more things that are passed in as dependencies. So all you're doing now is just kind of like taking a little bit of manual control over the turtle stack, but you're still just saying, give me an instance of thing, give me an instance of other, in the same way AutoWiring would have, but then you can also pass the API key. So this is the way you can pass things where it's a mixture of things, or not even necessarily auto-wired, things you want dependencies you want resolved out of the container versus dependencies you're going to manually resolve yourself, inject yourself. So here's one thing that you may have thought of, you might have run into, or you might have noticed, is that every time we do this, it's going to run that closure anew. So if you look at this only want one class, in its constructor, it is running string random and it's setting it to the ID. So every time we generate a new instance of only want one, it's got a newly generated random string assigned to its ID property. So we see 1 equals app only want one class, and 2 equals app only want one class. And then we die and dump and die them, and we get 2 separate strings because we have 2 separate instances that were generated here. And most of the time, that's fine. But there are some times when you want one to be shared, whether it's because it's using up a lot of resources or because there's some reason to share the state, whatever else it ends up being. So that's true for when you're using AutoWiring, which we're doing here, but it's also true for manual binding. Even when we manually bind that class in, it's still going to run that same closure 2 times and give us 2 different strings. But the good thing is there's a way to get around it, and it's called singleton. Singleton runs only once, and it's the exact same thing as app bind. You see, app bind only want one, app singleton only want one. Everything else is the same, but it used to be named bind shared if you've been around Laravel for a while. The only difference is that when you run that closure the first time, that result gets cached, and now every single time you request a new instance of only want one, it's just going to pass you that same one back that it got. It's not going to generate a new one. So when you run it 2 times, you now end up having the same ID, like you can see down in the bottom. And there's another way to do this singleton pattern if you want, and that is instance. Instance is the same as singleton, but instead of generating that single-use class that's getting returned over and over and over again in a closure, instead it assumes you already have it when you're doing the binding. So whether you got it out of a factory from a service class from some SDK, or you made it yourself, whatever you want, in the end, as you can see in like the 5th line here, original equals new only want one. We already have the instance that we want the container to return every time somebody asks for one. And now we say app instance, the class, and then that instance. Just like before, 1 equals 1, 2 equals 2. And when we dump and die, all 3, the 2 that we generated, the 1 we generated, the 2 we generated, and the original, they all have the same ID because they are all the same instance. And so those are singleton and instance are 2 different ways to basically say every time this thing's pulled, pull the same one versus a new instance of the same one. And the last piece we're talking about here is alias. And the only thing that alias does is it takes one of those string keys. And remember, up until now, the only string keys we've been using are class names, but that's not all that's available to you. What this is doing is saying that you can bind any string key to any other string key. And that does 2 things for us. First of all, we can now have shortcuts. You know, you can have OW. What we're doing here is setting it so that if I ever request OWO, it's going to give me the same thing as if I'd requested only want one class. So it's a shortcut. It's convenient. It's wonderful. But it's also showing us that these bindings don't actually have to be class names. They can be whatever you want, right? Because we just set it up to be OWO. And so we have what I'm calling alias freedom. We can bind to any arbitrary string as the key we use to get things out. And there's a couple great things here. One that is clearest is interfaces are bindable too. And so if you have, for example, type hinted interfaces all around, if that's how you work, then let's say you type hinted a mailer interface everywhere. Well, once conditionally, we can talk about that in a second, you can say anytime my code requests out of the container a mailer, mailer interface, give it a postmark mailer. And so what we did was we aliased it. Anytime somebody requests this one, give them that one. And so we now have bound our postmark mailer somewhere, but every single time the mailer interface is handled, we can get, and again, if we're talking about mailer, Laravel has its own inherent mailing stuff for switching these around. So you're not actually going to do this with mailer. But before Laravel handed that, you would have. And it's still just a nice kind of easy way to see that this is a thing that might end up having to be switched. So type hint for mailer everywhere, and then alias your mailer interface over to whatever your concretion is, your concrete class, and then now you're going to get basically that one postmark mailer every time. And it doesn't have to be anything real. Once again, you could alias my favorite interface thing or whatever to a class, and every time you ask for that thing, you're going to get that same class. So Laravel all over the place has these short aliases. And it's interesting because you're not going to see a lot in userland code. You're not going to see a lot of packages that use these little short names. Not a lot of people talk about it, but Laravel uses it all over the place. And you may not have noticed it. You may not have dug deep enough into the source code, but it's like at the core of how everything is bound into Laravel is these little short names. And as you can see here, you can get the word logger, and it's going to give you that same Illuminate log writer class using an alias. So if you've ever been to the documentation page about facades, you have probably seen that the right column here, which people tend to ignore, is called service container binding. And what that is those short strings I was talking about. So if you scroll down far enough on this page, you would see logger, Illuminate log writer. And what this is revealing to us is that all the kind of core services, which is why it's sometimes called the service container, all the core services, whether it's app or artisan or blade or whatever else, are bound into the container using a little short string. They're not just bound using a class. There's a couple reasons for that, and I think one of them is just history. But we'll cover them in just a second about some of the value there. But just know that if you want to do the same thing as the facade for app, if you want to access something that is Illuminate Foundation application out of the container, you can just replace the call for that full class name to app, and it will get it out for you. So here's one of the reasons, one of the big reasons why Laravel is using these short aliases, because each of those aliases doesn't just point to a real class, it also points to others. It usually points to around one class and several interfaces. It's not always exactly that. And so when you look at this, you see this aliases thing. This happens in the actual application class. There's something called register core container aliases, and it's a whole bunch of these. App yields these, and then config yields these. Every time I look at this, my brain says the thing on the left is a shortcut, and then we're telling it, now go bind the thing on the right into that shortcut, right? But that doesn't make sense because there's 3 things on the right, and 2 of them are interfaces. It's actually the reverse. Somewhere else in Laravel's Bootstrap, some service provider, and we'll talk about them in a second, has bound something useful to app. It's already done. It's already in there. And all of our service providers have already done those things right now. But now we want to make sure that in the places where someone realistically and justifiably asks for an instance of Illuminate Foundation application, or Illuminate Contracts Container, or Illuminate Contracts Foundation application, they now get the same thing, and it's the thing that it has a shortcut of app. And so what's going on here is it's really taking all of these classes and interfaces and everything and pointing them to this little short string, and somewhere else the short string is being bound. Now, first of all, this is clear because now there's not one class that has to be more important than the other classes. Because like right now I'd say, well, Illuminate Foundation application is important and the other 2 aren't. But that's not true, especially when we talk about using contracts, but also sometimes things split out to multiple classes or come back together. But the app is always going to be the app. So that string is actually like a more unique and more long-term key to represent this concept. I think that's probably the most useful piece about it. Okay, so common uses of automatic dependency injection using the container. The number one absolute most common thing is that you're going to explicitly ask to pull something out that is just like, give me this class, I want that class. And you'll either do it using the app helper, which we looked at earlier, or you'll do it by type hinting a constructor dependency or something like that. Number one most common use. We also have a few others. One of them is route model binding, and I'll cover all these in more depth in just a second. Another one is form request objects. And finally, it's just in your custom code, having the freedom to rely on constructor injection more often means you're more likely to reach out for other things like you actually should, rather than trying to do too much internal to one class. So let's go over these one after another. First of all, requesting classes from the framework, like the request or the log or the mailer, and your controllers and your jobs and your commands, whatever else. This is like 99% of the user-facing interaction with a container. And this one you're going to see because it actually comes out of the box like this. If we have a posts controller, we got a store method, which if you're not familiar is the one that takes a new post and you submit the form, it goes to this one. So we need to be able to get the information that you submitted out of that form, right? And so we would have used the post superglobal in the past, but we can now get that off of the request, only or request, there's all sorts of different methods you can call in the request, but you're basically doing them to get the submitted form information out. So we type hint Illuminate HTTP request in the method. And remember, we had talked primarily about constructor injection, but almost everything that happens in Laravel 5 allows you, if it's a system level user land class, like a controller or a job, you can almost always do method injection, which is so you type in something in the method here, not just the constructor. And since that method is getting called by the container, you can also automatically resolve those dependencies. So we type in Illuminate HTTP request, it automatically resolves it for us. And then we can now pass it into the validator. We can actually pull those fields off of it using request only. And now we've created something. That's really like 99% of when you're going to be using a container. But there's a few others that you might not even be aware of being container related. So route model binding is a thing where if you use the word post or comment or user or whatever in the route definition as a variable segment, as you can see there within the curly braces, and then you have a property for the method, and at this point it's a closure, but if it was a controller method would be the same thing that has the same name. So they're both named post, and then you type hint it with something. In this case, we're type hint it with an Laracon object. In this case, we're typing it post. Then what it's going to do is it's going to say, I presume that the thing that happened in that variable segment is the unique route key for an Laracon object of that type. Now, by default, the route key is going to be the ID, but you can change that if you want with the method on your Laracon object. But let's say it's the ID. It's going to assume that post/whatever is going to be the unique key for a post. And so before it even gets to your userland code here, it's going to say, look up a post with the ID of whatever came in through here. If it exists, pass it in as the post object, and now you can work with it. And you don't have to do a lookup and validation in the first line of your controller method. But if it doesn't exist, just throw a 404 or whatever else it ends up being. So that's really convenient. And it's just type hinting. It's just dependency injection with a layer of intelligence on top of it. And form requests are the same thing. It's saying when you get a form submitted, it makes it really easy to have a structure around authorizing the user to do what they're doing and validating their input. Those are the two primary things that you're going to be doing there. And so it encapsulates those two very common things into a separate class called a form request. So if you say update, and then you say update post request, what it's saying is, I expect that there's a form request object somewhere named update post. And what you should do is go and look at its rules and go look at its authorization rules on this HTTP request right now and make sure they're good. And if not, before I even get into my controller method, go kick back a validation failed response or an authorization failed response. And I don't need to go any further there. You can look it up in the Laravel docs. It's very good. But in essence, this is just another type hinting dependency injection with a little bit of magic on top. It's a little bit more intelligence. Finally, relying on constructor injection more confidently in our custom classes. This just means when you're writing your own custom class, you don't have to feel like either newing things up or just doing the work yourself. It's something about having easy access and easy, well-architected testable access to dependencies that just makes you more likely to rely on them when it's time. And that's a really helpful thing. Now, you don't want to totally clutter it up. You don't want a constructor with 25 different parameters, but the ability to use them when you need them is something really valuable. So you can see here, supposing I'm making a joined-in client and I need a guzzle client so I can make guzzle calls. I need a logger and I need a cache call. Great, I just inject him, and I assume that every time I new up this client, I'll be using I'll be using app make, and then I'm good to go. Bonus goodie, we already talked about this a little bit, and I said that anytime that you make a call on a method in a constructor or something else like that, Laravel will be using that thing. How do you say it? It'll be using the container to resolve that method, right? So it's possible for you to do that on your own. It's not just something that Laravel can do, or to call that method, I guess is the best way to say it, and then resolve its dependencies. So if you do one of these two up at the top, you either do app call and then an array. First object of the array is the object that you're calling the method on, and the second object, second thing you're passing in is the name of the method. That's one way. Or you can just use this kind of shortened syntax that you're probably familiar with anyway, which is class name at method. So if you were to say, for example, app call and then pass the array syntax, you could call it on the object you're in at the moment, or some other object, whatever, and then the method name. So this method name is do thing with the dependencies, and it'll handle your dependencies, it'll resolve them, and it'll call it injecting those dependencies in. Or you can say call synchronizer at activate, or you can even pass parameters in. You got a client with a get method that takes a single parameter that's the route. Great, pass that route in. You're good to go. Okay, next important thing is service providers. Now, this is a tiny little bit less important because Taylor talked about it a lot in his talk, but I'm going to go over everything anyway because I think it's really valuable to get this and why it matters. So in Laravel, service providers are the central location for you to bind services for use by your application's code. They're usually grouped by functionality, so you've got an event service provider and a broadcast service provider or whatever else. And it's where all of the bootstrapping, or almost all the bootstrapping, there's a tiny little bit outside of it, takes place. And over time, more and more bootstrapping has moved into service providers, and less of it lives in procedural lines of code. Recently, I wrote a blog post for Twilio where they asked me to write up how to connect to Google Spreadsheets in PHP. And the caveat I had to make there is that with Google, you're doing two things. First of all, you're doing this whole dance of authentication. You have to have the settings right, your Google spreadsheet, and you have to make sure that you got the API key put in separately, correctly, and then you get a token and you're doing, handling exceptions, all this kind of stuff. And it's 20 lines long and it's kind of hairy, and you have to do it every time. And I said, okay, if you're writing vanilla PHP, throw this up at the top or throw this in a common file. But if you're writing Laravel, go create a Google service provider or a Google spreadsheet service provider, throw that in the boot method, and then now you never have to worry about it. And the simpler code, which is the actually consuming Google spreadsheets, is the only thing you actually need to write each time instead of writing it over and over again. Now, there's a little more complexity than that, but in general, service providers are doing the kind of like gross, repetitive, or just kind of like foundational basic stuff of getting everything ready so that your code can work. But it's not the code that does the things, it's the code that prepares the things, if that makes sense. So let's take a look at the anatomy of a service provider. The first thing you've got is the register method, and it's the most commonly used aspect of the service provider. The register method is all and only for binding services in the container, which is what we've been talking about this whole time. App bind, app singleton, app alias, whatever else it ends up being, that should all live in here. And the reason, which Taylor said in his talk, but I'll say again, is because they all run register on all the service providers before anything else. And so if you are trying to do some work that relies on, for example, the event service provider having run and your service provider runs before it, that's going to fail. So you don't register your event listeners. You don't register your routes because the route service provider may not have run or whatever else. You're only doing bindings, which means there shouldn't be any behavior being triggered because those closures in your bindings don't run until they're actually called, right? Only binding should happen. And therefore, all your register methods will run. And then after that, all the boot methods will run. And so the boot methods are where things happen that are bootstrap but aren't binding. And when boot runs, you can assume that everything is already bound. And so now you can do event listeners, routes, or whatever else it ends up being. So register is by far the most common. Boot is the next most common. But there's two other ones. There's a defer property, and then there's a provides array. So by default, all of your service providers get hit on every load, and you don't always want that to be the case. And so the defer property says avoid or defer, push it down the road, running the service provider if certain bindings aren't requested out of the container. And when they are, then go run the service provider, right? So it basically just means don't run this thing until these bindings are asked for. Someone tries to resolve one of these things. And so the benefit of that is if this service provider is useless unless you're looking for just this thing, right? So in my Google service provider example, it was unless somebody asked for the Google spreadsheet client, I don't need to run those 20 lines of code. So I would have said defer true. And then in the provides array, you're telling it what keys, so what classes or interfaces, whatever else, should trigger this service provider being run. And so I would say, the Google spreadsheet service provider and the Google ID service provider, or Google spreadsheet client and the Google service whatever thing for getting your ID or your token, right? And so until any of my code called one of those, try to get them out of the container, this wouldn't even run. So let's take an example of one of the service providers that comes out of the box. The broadcast service provider is deferred. So we have a register method, and all it's doing is registering a whole bunch of classes, which you can see I shortened. It's got two singles, and it's got an alias. And then it's saying, and it provides these three classes, which you can see are the same three that we're registering there: broadcast manager, broadcasting factory, and the broadcaster contract. And one of them's not a class either, is an interface. So what we're saying here is basically this service provider does these three things. It makes these three things available to the container. And when these things aren't asked for, it shouldn't even run. Therefore, defer provides. So most code things never even hit the broadcast service provider. Finally, you hit one, it asks for broadcast manager out of the container, and the container looks at this and it says, oh, this provides it. I got to go run this once before I pull it out. Quick aside, the app service provider is something that comes either empty or close to empty out of the box, and it's just the place to kind of dump things where you're bootstrapping, and it's either a single line or you're not sure how the things that you're doing in your bootstrapping and the things you're binding are going to end up grouping together. So you don't know if there's going to be a specific service provider for this or that. You throw them in the register and boot methods of the app service provider, and they may stay there forever, but more like you'll throw them in there, and then at some point you'll notice that you have 15 lines in there, and you'll start extracting them out. But that's a good kind of generic place to start if you're kind of getting overwhelmed by some of the service provider talk. So if you're developing third-party packages for Laravel, and Taylor mentioned this in his talk as well, service providers are your hook. They're the way that you provide functionality, provide hooks into Laravel and Laravel applications, and you have incredible power there, and that really should be almost the only place you interact. You could also publish things. But basically, that's kind of what you should be working with. And so you can put routes into their application. You can bind events, and you can register things into their container or anything else, because all the things that Laravel is doing to boot itself, all the things that we're doing to write our userland code, those are all available to a package developer as well. And they can get all that stuff in there using service providers. So if you've ever installed a package that is Laravel specific, you probably were asked to do two things. Go to config/app.php and put in a service provider, which runs that service provider, and then provide an alias, which is a little bit less common. And so that's a perfect transition for us to talk about facades. Facades. Oh, sorry, I was just really thirsty. So the reason that you've probably heard people talk about facades this way, and the reason I just had a nuclear explosion gif, is because there's some drama around facades. Thankfully, it's almost gone, which means I almost shouldn't talk about it. But I'm going to talk about it because it's silly. And so if you hear it come up again, don't let it bother you. The two big dramas around facades are, one, the thing that's a facade in Laravel is not technically a facade. So first of all, that doesn't matter. And I'll fight you later if you care about it. But second of all, it really is a facade. But Again, it doesn't matter, but it actually really is. But okay, cool. But the second one that's more important is that facades are static classes. They're static calls, and therefore they're less testable. And this was commonly kind of spouted around, and it's a load of crap. We'll talk about that a little bit later, but facades are actually more testable than most of the things that they replace. So don't worry about the drama. I'll fight you in the parking lot later. If you want to worry about the drama, not really. I'm a pacifist, but we can go get coffee or something, and I'll tell you why you're wrong. So if you've never worked with facades before, you've got stuff like route : get. If you're used to PHP, you know that that is a static method call. Log : info, db : statement, whatever else it ends up being. They're these static method calls that provide a very easy syntax. You don't have to say new router and then router get. You just say route : get, and that's it. So a facade, and this is my definition, I don't know if this is totally right, but this is how I think about it. It's a convenience class that provides static access, so static, the : to non-static methods. And that's the thing we haven't covered yet. Those are non-static methods on their originating classes on classes resolved out of the container. So it's a convenience class that provides static access, which means it's short, it's easy, it's in line. You don't have to new something up first, to a non-static method. You don't have to write all your methods statically and therefore, hurt your testability, whatever else, on classes resolved out of the container. So the way that you define a facade is very simple. You have a single class, usually it's only a couple lines long. It extends facade. It has a single method called getFacadeAccessor. And whatever string you return there is the string it's going to use to look up the class that it's backing or is being backed by out of the container. So when it returns the string cache, what that really means is when you run cache : get, it's the same as running app parens cache get, and that's it. And I feel like this has been this kind of like magic thing that people haven't totally understood, and that's part of why it's been so scary. All you're doing is saying somewhere in this container, there's something bound with this string. So instead of returning cache, you could return the fully qualified class name. You don't even have to have a short name if you don't want. And all it says is app, get a single instance, and run it on that single instance. So you can create your own facades very easily. All you got to do is bind your class to the container, however you want, either using its own name. Actually, you know what? I wrote these all out. So bind your class to the container, define the facade class, and point it to your bound class name and profit. So let's walk through them. 1, bind your class to container. Again, you could bind it using its own class name. It could not even need manual binding. It might be AutoWirable. Great. And then you figure it out, so it's now bound just like normal. 2, create a facade class, put it in the right place, and point it to your bound class name. So this one we just bound as the short string Twitter. Great. We said that getFacadeAccessor is Twitter. But again, it could have just been the fully qualified class name and you're done. And that's it. You can now use it with Twitter : any of the non-static public methods that are available on your instance. And then, of course, profit ostensibly. There is a new thing that came out in Laravel 5.4 that's called a RealTime Facade. If you prepend facades / to any namespaced class anywhere within your application, when you either import it or you'd reference it in line, you can now use it as if it were static. So if you've got this class thing and it's got a method do, normally to use it, you'd have to say new thing, arrow do. And you could create a facade. You could go say class thing extends facade, function, private public function, getFacadeAccessor, return thing, right? And then you could use it that way. But with this RealTime Facade, all you have to do is just take the exact class and put facade / in front of it. That's it. And now when you call it, it goes do, you're good to go. Brilliant, beautiful, terrifying in a good way. All right, last thing. Testing and the container. So again, facades have terrified people on a lot of these things. Oh, you're using service locators, it's terrible for testing. Well, it turns out, and I don't need to say this is not fresh anyway, but I'm going to say it anyway, that's all a load of crap. And the container and dependency injection, all these things make it brilliant to test. And facades actually make it brilliant to test. So the container aids in dependency injection, and the number one reason for the popularization of dependency injection as a design pattern is for the ease of testing, because it's so much easier to pass in a test or a mock or a stub or a fake or whatever in while you're testing than it is to change something that's being newed up internally, right? Like I can just say, give me a fake mailer and pass it in to a constructor parameter and I'm done. But if it's something inline says new mailer, it's going to be really hard to change that while I'm testing. So in my code, you can see what I'm doing right here is maybe let's say I'm just returning using the myService class, I'm saying get whatever, right? So if we want to test that, all we do is change the binding for the myService class to return something different. So as you can see in test, I'm saying make a mock of the myService class and overwrite the pre-existing AutoWiring or even a pre-existing manual binding, whatever, and now say every time somebody asks for the myService class, return this mock instead. So now if we integration test that route get, all of a sudden this service object that we're working with is going to be an instance of my mock. Done. Because we asked for that thing and got a dependency injected, we're done. That's it. It also works for facades because facades are just reaching into the container and asking for that certain string. Remember that we bound one that's looking for that Twitter string. So if I'm doing the Twitter facade, Twitter : post, here's my status. Great. All I got to do is make a mock of my Twitter client, and then I got to set it to the Twitter string. And I know that the Twitter facade is pointing to that Twitter string. And now when I use that Twitter facade in my tested code, my integration tested code, it's going to be pointing to my mock instead. Done. And there's even better, there's facade specific mocking and spies. And almost all your facades, you can do this. You basically treat it like an instance of mockery, and you could say cache should receive get with key, return value, done. And there's also specific ones. So while Adam Wathan was at Titan, he wrote this thing called Mail Thief, and we're upkeeping it now, that basically allows you to hijack a facade where this is, it's not this simple. You need some more kind of very specific stuff. You can hijack the facade and say, well, mail should have received email here or should have a subject here or whatever. And so we wrote Mail Thief and we still maintain it. And Taylor has actually built a whole bunch of those in. And so now a lot of the native classes have not just this cache should receive, but they have this whole complex set where you can hijack it and start setting very context specific assertions against those classes. So again, there's actually way more cool stuff we can do with testing here than we can on just our normal classes. Okay, we're almost done. A few miscellaneous pieces and then we're done. First, you can also, in later versions of Laravel, I don't know if it's 5.3 or 5.4, you can bind arbitrary values. And so let's say there's something you just want to put in and you want to get it out later, and it's not a class and it's not an instance, it's just an array. For example, an array of all the countries in the world. Great. You can bind the string countries to that array, and then when you say app countries, it's now going to give you that array. Done. Careful not to overuse it, but I mean, whatever, you now have a universal locator for useful pieces of information, and sometimes that's the right way to do it. Another one, this is not used as often. I wouldn't say you should probably go do this. Probably write things the way we're writing, but I want you to see this just so you know what the syntax means. The container has array access available, which means if you use an array access instead of arrow make, then or arrow bind, then you have the ability to basically bind and resolve things using array access. So as you can see, we can resolve by doing logger equals app logger, and that's it. So we just now said, give me an instance of logger. But below that, in the mailgun mailer and the countries, we're also able to bind. And what we say is app mailer equals new mailgun mailer, or app countries equals Afghanistan. And now we have bound those in there, and just as if we had done make or singleton or whatever else. One more piece of miscellany. Contextual binding says, when this class asks for this, give that. And when this class asks for this, give that. And so the context that I've seen this happen the most is, for example, Postmark, I think it's Postmark, I hope it's Postmark, is a fantastic mailer. It's the one that was run by the people who do Beanstalk, and I think that's Postmark. They're a great mailer that doesn't allow you to send marketing emails. I think that's what it was. And so I wanted to use them, but I couldn't use them for my marketing emails. So I used them for my user-facing emails, and then I had just a really small account that I used for my marketing emails. And let's say that I'm right, and that's what was going on. So if the newsletter sender wants to send something, the mailer needs to give it mailgun mailer, because otherwise I'm going to lose my account. But everything else, or the notifier, or the user notifier, or whatever else, if it asks for that mailer, give it the Postmark mailer, because that's what I wanted to use. So contextual binding allows you to define, just in specific cases, to change kind of how you're going to do that. So that is it. Just short on time. There's a million other things we could talk about, but I hope this gives you a high-level overview. The number one thing I want you to walk away from is to not treat, even though it is magical, to not treat the container and the application as some magical thing that just kind of does your bidding. When I was writing my book, that the container chapter taught me more than maybe any other chapter. And I see more and more people say, man, I loved your book, but that container chapter just blew my mind, because I feel like it gives you a view behind the scenes of what Laravel is actually doing. And like I said, it's one of the kind of 3 pillars of what Laravel actually is. And so if you have like a really great ability to understand how the container works and what it's providing and how to make it do your whims or whatever, I really think that's going to be a big step up in your ability to developer. So that's it. Thank you.
All right. Amazing job.
Thank you, sir.
Containers, like one of those mind-blowing things, just so involved in everything. So got a couple questions. There's some more complicated questions in there that I'll leave to, if you have a little
Sure.
time after to go through your luck. I don't want to have to like describe code, but or as much as I can avoid that. But I have a couple here that I picked out. So one, and I don't know if you know this off the top of your head,
Probably
but
not.
in 5.4, the container no longer accepts the second array of
I
parameters.
knew someone was going to say that.
Yeah, so he was asking for suggestions, a factory.
Yeah. So the short of this is basically app arrow make, which allows you to say create one of these things. Prior to 5.4, you could optionally pass two parameters in. The first parameter could be the class name and the interface name, whatever. And then the second one optionally could be an array of the properties that couldn't be resolved that you wanted to be different every time. So if you remember in the talk that I gave, I said, let's say the API key. You can't auto-wire the API key, but you can bind it once at the beginning and you're good to go. But what if it's something where every time you make it, you want that thing to be different? Let's say, maybe this thing is responsible for creating a client, but the client could call for 5 different types of content. So a lot of people would say app make client, and then the next parameter would be basically the, posts or contacts or whatever. That went away in 5.4, and there's this huge comment thread, people saying, that's how I'm used to writing. What am I going to do here? So in short, what you're doing in that context, knowing it or not, is you're using the container as a factory. You're using the container to make your things. And so Taylor's answer has been, because we support that, it actually makes things a lot more complex, and it makes it a lot less clear what the container does. So we're not going to do that anymore. Instead, what we're going to do is we're going to ask you to make a factory in that context. And somebody can hit me up later and I can show you examples of factory code. It's a little bit of a switch and it's a little bit of surprise, but just know that even though it feels like your whole world is crumbling when that happens, it's actually a very, 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 very small subset of people using AppMake that did it that way. And so it's just this kind of gentle shifting of like, it's time to use a factory there. That's kind of how I've read it. Now, I haven't been involved in that conversation at all, but I try to read everything, so that's as best as I understand. So
an amazing job. You're down in there in the comments of
yeah, man.
Threads. All right, so one more. So that's good. You were prepared for that one, see? All right. So this one I think is a little bit simpler, but what's your take on injecting into the constructor versus just into the method that needs it?
Yeah, I mean, I would say that the times where you think of the thing where either this class really exists to provide the method. That's it. So think about like a job or a command or something like that. The class really exists to provide the fire or handle method. It makes sense in that context. And often, especially the way Laravel structures things, you're putting data into the constructor, but you're making those calls. You're making those calls out of. You're putting data in the constructor, but it's actually being called via the method. And so it's being called via the method, and that is really the place where, like, at time, that's what it is. When you pass the data in, it's when you're creating the thing. You're creating a service that does whatever. You're creating a job. And then when you call a thing, that's really when it's appropriate for the dependencies to be injected if possible. Similarly, when a controller is constructed, it really doesn't matter. The construction point of the controller is somewhere back in the original source of the world, right? Like who cares? I don't know. It's when the controller method is called that actually matters the most, right? And so those are the times where I think it's really appropriate to pass things in. I would say otherwise, if it's not a time where the thing really exists around the method or exists around the fire or the handle or whatever, otherwise put it in the constructor. So
awesome. Hold on. Let's see. Yeah, there's a couple more questions here. Is there anything obvious? No. Okay. All right. We're going to let you go there. Fantastic job.
Thank you very much.
As always. Love having you close it out. It's perfect. With a deep Laravel dive to close it out, which is great. So hang out in the chat. There's a couple questions for you in there. And then I'm just going to wrap things up out here.
All right. Thank you, sir.
All right, let's see. All right, everybody. So let me just do a little bit of business here.